Imagine walking across a silent desert at dusk and realizing the ground beneath your feet once held cities, vast, intelligent, and completely forgotten. Not ancient human cities, but something older, something that thought, built, and vanished so long ago that even time itself has almost erased the evidence. Now ask yourself, what if we didn't rise first, but simply arrived last?
We like to imagine ourselves standing at the beginning of something, at the dawn of intelligence, at the edge of awareness, at the very first moment the universe looked back at itself and understood. It's a comforting idea, almost poetic. Humanity as the first mind to rise from Earth's chaos, the first to ask questions, the first to shape the world with intention instead of instinct. But comfort and truth are not always the same thing. Because when you step outside that belief, just for a moment, and look at Earth not as a human would, but as time itself would, something unsettling begins to take shape. You realize that we didn't arrive early. We arrived impossibly late. No ruins, no monuments, no warning signs carved in stone. Just silence. So the question changes. It's no longer where is the evidence, it becomes would we even recognize it if it existed? Because our search for the past is built on expectations. We look for bones in the fossil record, we look for tools, structures, patterns that resemble our own behavior. But what if the first intelligent species didn't leave bones like ours? What if they weren't land-dwelling creatures building cities and shaping stone? What if their intelligence expressed itself in ways that don't fossilize, or don't survive, or don't resemble anything we understand as technology? The deeper you think about it, the more unsettling the idea becomes, because it suggests something quietly profound. We may not be failing to find evidence, we may be failing to recognize it. The fossil record itself, often treated as a complete history of life, is anything but complete. It's fragmented, selective, biased towards certain conditions and materials. Most organisms that have ever lived on Earth left no fossils at all. Soft-bodied creatures vanish without a trace. Entire ecosystems can disappear, leaving only faint hints that they ever existed. And even among the fossils we do find, the story is incomplete. Gaps stretching across millions of years, missing chapters that no one can fully reconstruct. If intelligence arose in one of those missing chapters, how would we know? There's another assumption we rarely question, that intelligence inevitably leads to permanence, that once a species becomes aware, builds, creates, and evolves, it leaves behind something lasting. But history, even human history, suggests otherwise. Civilizations rise and fall, languages vanish, knowledge is lost, entire cultures disappear, leaving behind only fragments that archaeologists struggle to piece together. Now imagine that process, not over centuries, but over geological time. What remains after millions of years isn't the story. It's barely even the outline. And then there's the deeper, more unsettling thought. What if intelligence is not rare? What if, given enough time, it emerges again and again, in different forms and different environments under different conditions, not as a single unique event, but as a pattern, a cycle, rising, adapting, reaching a peak, and then fading away? If that's true, then humanity might not be the first to ask questions about existence, not the first to map the stars, not the first to wonder if they are alone. We might simply be the latest. But if others came before us, why is there no clear trace? No unmistakable signature, no undeniable proof? That's where the illusion of first becomes strongest, because absence of evidence feels like certainty. It feels like confirmation. But in a world where time erases almost everything, absence doesn't mean what we think it means. It doesn't prove we are alone in the past. It only proves that the past is very, very good at hiding. And maybe that's the most unsettling idea of all, that Earth has lived through stories we will never fully know, worlds within worlds, Eras where life evolved, adapted, and perhaps, just perhaps, became aware of itself long before we ever existed, only to vanish so completely that their existence feels impossible. But as we move deeper into this idea, one question begins to take shape. Not loud, not obvious, but persistent. If intelligence could have existed before us, in forms we don't recognize, in times we can barely imagine, then what exactly are we standing on? Not just soil and rock, but layers. Layers of time, layers of forgotten worlds, layers of possibilities we've barely begun to consider. And somewhere within those layers, buried beneath millions of years of change, might lie something we've never truly looked for. Not because it isn't there, but because we've always believed it couldn't be. And that belief is about to be challenged.
Stand anywhere on Earth, on a crowded street, a quiet field, or the edge of an ocean, and try to imagine what was here before. Not 1,000 years ago, not even 1,000,000. Go deeper. Imagine peeling back the ground beneath you, layer by layer, like pages in a book written over billions of years. Each layer tells a story, but most of those stories are incomplete, torn, smudged, rewritten by time itself. Because the Earth you see now is not the original version. It's the latest draft. Long before humans, before mammals, before even the dinosaurs, the Earth was already ancient. The continents we know today, Asia, Africa, the Americas, didn't exist in their current form. They were fragments, drifting slowly across the planet's surface, colliding, breaking apart, reshaping themselves over and over again. At one point, nearly all land was joined into a single massive supercontinent, Pangaea. Before that, there were others, Rodinia, Gondwana, each one forming, existing, and then dissolving back into shifting pieces. Entire worlds, assembled and erased. If something had lived there, something intelligent, something complex, those continents would have carried its traces, only to scatter them across the globe as they broke apart. What once stood together would now be separated by oceans. What once was visible might now lie buried deep beneath layers of rock, or lost entirely beneath the sea. Because the surface of Earth is not stable, it moves, slowly, relentlessly, without pause. This movement, plate tectonics, is one of the most powerful forces shaping our planet. It recycles the crust itself, pulling old material down into the mantle and pushing new material upward. Ocean floors are constantly created and destroyed. On average, no oceanic crust survives longer than about 200 million years. Think about that. Anything that once existed on ancient ocean floors, any structure, any trace, any sign of activity, would be gone, completely erased, melted back into the Earth. And since most of the planet is covered by oceans, most of Earth's surface history has already disappeared. Now imagine a civilization, not human, not necessarily anything like us, that emerged hundreds of millions of years ago. Maybe it thrived along coastlines that no longer exist. Maybe it developed in regions that have since been swallowed by subduction zones, dragged deep beneath the surface and destroyed. Maybe its entire world now lies miles beneath the ocean, unreachable, unrecognizable. Would we find it? Or would we simply walk above it, unaware? Even on land, survival is not guaranteed. Mountains rise only to be worn down by wind and water. Rivers carve through rock, carrying sediments across continents. Glaciers grind landscapes into dust. Volcanic eruptions bury entire regions under layers of ash and lava. Over millions of years, the surface is constantly rewritten. A structure, no matter how strong, cannot resist that kind of time. Stone crumbles, metal corrodes, everything eventually returns to the cycle. And when it does, it becomes indistinguishable from the natural world around it. There's a place in Western Australia where some of the oldest rocks on Earth can still be found. They are over 3.5 billion years old. Tiny formations within them, stromatolites, are among the earliest evidence of life on this planet. They are simple, layered, barely recognizable as biological at first glance. And yet, they represent something extraordinary, the first known traces of living systems shaping the Earth. But even these traces are rare. For billions of years, life existed and left almost nothing behind. No bones, no shells, no structures, just faint chemical and geological signatures preserved by chance. If something more complex had existed during those early ages, something intelligent, would it look any different in the rock? The deeper we go into Earth's past, the more alien it becomes. There were times when the atmosphere had almost no oxygen, times when the oceans were filled with chemicals toxic to most life today, times when the planet froze over almost entirely, a snowball Earth where ice covered vast stretches of land and sea. And yet, life survived.
Adapted. Evolved. Again and again. Each era feels like a different world, with different rules. And in each of those worlds, there were opportunities, millions of years long, for complexity to emerge. We like to think of the fossil record as a library, a vast archive of Earth's past, where every creature that ever lived has left behind a page, a bone, a shell, a footprint pressed into ancient mud. We imagine it as a continuous story, stretching from the earliest life forms to us. But that image is comforting, not accurate, because the fossil record isn't a complete library. It's more like a handful of surviving pages, scattered across billions of years. Most life never fossilizes. That's not speculation, it's a quiet reality of how preservation works. For something to become a fossil, an almost impossible chain of events has to occur. The organism must be buried quickly, protected from scavengers, shielded from decay, and preserved under just the right chemical conditions. Miss even one step, and it disappears. No trace, no record, just absence. Now consider this. The vast majority of organisms that have ever lived on Earth were soft-bodied. No bones, no shells, no hard structures to leave behind. They moved, lived, and died, and then dissolved back into the environment. If an entire ecosystem were made of such organisms,
it could exist for millions of years and leave almost nothing behind for us to find. No fossils, no clear evidence, just silence. And yet, we often assume that intelligence, if it existed, would leave behind something unmistakable. A skeleton with a large brain cavity, tools made of stone or metal, signs of manipulation in the environment. But that assumption depends on something very human. It depends on the idea that intelligence must look like us. What if it doesn't? What if the first intelligent species wasn't built for land, but for water? An ocean-dwelling organism with no bones, no rigid structure, just flexible, adaptive forms moving through deep, ancient seas. Something capable of learning, communicating, perhaps even shaping its environment in subtle ways. Would it fossilize? Would it leave tools? Or would its entire existence vanish the moment its biological structure broke down? Even on land, the story is incomplete. Take the dinosaurs. They dominated the Earth for over 160 million years, an unimaginable span of time compared to our own existence. And yet we have only fragments of their story. We reconstruct entire species from partial skeletons, sometimes just a few bones. We infer behavior from footprints, environments from sediment layers, diets from tooth shapes. It's an extraordinary achievement of science, but it's still interpretation, a reconstruction built on limited evidence. Now imagine trying to detect intelligence in that kind of record. Not obvious intelligence like ours, but something subtle, something that doesn't carve stone monuments or build lasting structures, something that leaves no tools, no large-scale alterations, no clear markers. Would we see it? Or would it blend into the background, indistinguishable from natural processes? There's a deeper problem. The fossil record is biased. It favors certain environments, places where sediment builds up slowly, where conditions allow preservation. Deserts, mountains, tropical forests, vast regions of the Earth leave behind far fewer fossils. Entire ecosystems can exist in those environments and leave almost nothing behind for us to find. If intelligence arose in one of those regions, its chances of being recorded are even smaller. And then there are the gaps. Not small gaps, massive ones. There are periods in Earth's history where the fossil record becomes thin, fragmented, almost empty.
Millions of years where we have only scattered evidence of life. These gaps are not just missing details, they are missing chapters, entire stretches of time where we cannot clearly see what was happening. And within those missing chapters, anything could have existed. There's a moment in Earth's history known as the Cambrian explosion. Around 540 million years ago, life suddenly diversified in an extraordinary way. Complex organisms appeared rapidly in the fossil record, creatures with eyes, limbs, shells, and new body structures. It feels like a beginning, like the moment complexity truly arrived. But it wasn't. Life existed long before that. For billions of years, simple organisms lived and evolved, leaving only faint traces behind. The Cambrian explosion doesn't mark the start of life. It marks the point where life became easier to preserve. That distinction is critical because it reminds us of something we often forget. The fossil record doesn't show us when things began. It shows us when they became visible. So if intelligence arose in a form that didn't fossilize well, or didn't create lasting structures, or existed during a time with poor preservation, its entire story could be missing. Not because it didn't happen, but because it never crossed the threshold of visibility. There's another layer to this silence. Time doesn't just erase organisms, it reshapes the evidence they leave behind. Fossils are not perfect snapshots. They are altered, compressed, mineralized, distorted by pressure and heat. In some cases, entire structures are replaced molecule by molecule, turning biological material into stone. Over millions of years, even fossils themselves can be destroyed, recycled, or transformed into something unrecognizable. So even when something is preserved, it doesn't remain unchanged. Now imagine something even more complex.
an organism that uses organic materials for tools, structures made of biological compounds rather than stone or metal, shelters grown instead of built, technologies based on chemistry or biology rather than mechanics. These creations might function perfectly in their time, but leave nothing behind. No artifacts, no clear markers, just a return to the environment. If such a species existed, it wouldn't leave ruins. It would leave absence, and absence is easy to ignore. There's a subtle psychological effect at play here. When we look at the past and see no clear evidence of intelligence, we don't interpret that as uncertainty. We interpret it as confirmation. We say, nothing is there. But what we're really seeing is the limit of what can be preserved and what we can recognize. And recognition is shaped by expectation. We look for patterns that match our understanding. Skulls with large brain cases, tools with deliberate shaping, structures that resemble architecture. But if intelligence took a different path, if it expressed itself in unfamiliar ways, we might not recognize those patterns at all. We might classify them as natural, as anomalies, as curiosities, and move on. There's an unsettling implication hidden in that idea. It suggests that evidence of past intelligence could already exist within the fossil record itself, not as obvious discoveries, but as misinterpreted ones, overlooked, dismissed, cataloged under categories that don't quite capture what they are. Because the fossil record doesn't speak clearly, it whispers. It leaves clues that require interpretation, and interpretation is never perfect. As we continue to dig, analyze, and study, we are constantly rewriting our understanding of the past. New discoveries reshape old assumptions. Fossils once thought to belong to one species are reclassified as another. Entire timelines are adjusted as new evidence emerges. The story is not fixed. It evolves, just like life itself. So when we say there is no evidence of intelligent life before humans, what we might really be saying is, we have not yet learned how to see it. And that possibility changes everything, because it means the silence in the fossil record is not necessarily empty. It may be incomplete, layered, misleading, a quiet space filled with things we haven't recognized yet. As we move forward, the question becomes even more unsettling. If the fossil record cannot reliably capture all forms of life, if entire ecosystems can vanish without a trace, if evidence can be altered, lost, or misunderstood, then what about something more durable? Something we assume would last, something we believe would leave an undeniable mark. What about technology? If intelligence existed before us, surely it would have built something that time could not completely erase, something that would still be visible today, right? That assumption feels solid, logical, reassuring. But as we step into the next layer of this mystery, we begin to realize something unexpected. Even technology is not as permanent as we think, and what it leaves behind may not look like evidence at all.
We trust in our creations. There's an unspoken belief woven into modern life that what we build will outlast us. Steel, concrete, satellites orbiting silently above the Earth, it all feels permanent, as if our intelligence has finally carved something into the fabric of time that cannot be easily undone. But permanence is an illusion built on short timescales, because the moment you stretch time far enough, even the strongest things begin to fade. Picture a city, not an ancient one, but a modern one. Towering skyscrapers, highways stretching to the horizon, power lines humming with energy, data flowing invisibly through networks that connect billions of minds. Now imagine that city without people, not destroyed, just abandoned. At first, nothing dramatic happens. Lights go out, systems fail, silence replaces motion. Then, slowly, the world begins to take it back. Within weeks, plants start pushing through cracks. Within years, water seeps into structures, weakening foundations. Metal begins to rust. Glass shatters under shifting pressure and temperature. Decades pass, and buildings lose their integrity. Roofs collapse, walls crumble, roads fracture and sink. Give it a few centuries, and the skyline disappears. Give it a few thousand years, and you would struggle to prove a city was ever there. Now extend that process, not thousands of years, but millions. The remnants that survive erosion are buried. Tectonic forces shift the land. Sediments cover what remains. Heat and pressure alter materials at the molecular level. What once was engineered becomes geological. A beam becomes ore. Concrete becomes stone-like sediment. Everything blends into the earth, and the distinction between natural and artificial begins to blur. This is the first crack in our assumption that technology, by its nature, must leave behind something unmistakable. But over deep time, it doesn't. It dissolves into the same processes that shape everything else. Consider metal. Steel feels strong, durable, built to last. But exposed to the environment, it corrodes. Oxygen reacts with iron, breaking it down into rust, a material far weaker and far more vulnerable to further decay. Over long periods, that rust disperses. It mixes with soil, water, and other minerals. Eventually, what once was a carefully engineered structure becomes part of the background chemistry of the Earth, not an artifact, just elements. Now think about plastics, one of the most persistent materials we've ever created. Plastic doesn't simply vanish. It breaks apart into smaller and smaller fragments, becoming microplastics, then nanoplastics. Over enough time, even these degrade, altered by sunlight, chemical reactions, and biological processes. What remains is not a recognizable object. It's a subtle shift in chemical composition, a faint signature, easy to miss. Even our most advanced materials are not immune. Silicon chips, the foundation of modern computation, degrade over time. Their delicate structures break down. Their information, everything they once stored, is lost. Satellites drifting above us now will eventually fall. Some will burn up in the atmosphere, others may survive impact, only to be weathered, buried, and transformed. Given enough time, even the evidence of our digital age becomes invisible. So if a technologically advanced species existed millions of years ago, what would we expect to find? Not intact machines, not functioning systems, not even recognizable tools. We might find nothing obvious at all. But nothing doesn't mean absence. It means transformation. There's a concept that begins to emerge here, something scientists sometimes refer to as a technosignature, not a structure or an artifact, but a detectable change in the environment caused by technology, something subtle, something indirect. For example, certain industrial processes leave behind unique chemical ratios. Burning fossil fuels releases carbon in a specific isotopic pattern, one that differs from natural sources. Large-scale manufacturing can concentrate rare elements in unusual ways. Nuclear reactions produce isotopes that don't commonly occur in nature. These are not visible structures. They are fingerprints, faint but measurable. Now imagine this. An advanced civilization rises, develops technology, alters its environment, and then disappears. Millions of years pass. Its cities crumble, its machines decay, its materials break down and merge with the earth.
But some of those chemical fingerprints remain. Not obvious, not dramatic, just slightly out of place. A layer of rock with an unusual isotopic ratio, a concentration of elements that doesn't quite match natural processes, a thin geological boundary that hints at something different, but doesn't explain itself. Would we recognize it? Or would we attribute it to natural causes? A volcanic event, a shifting climate, an unknown geological process? Because that's the challenge. The deeper we go into time, the harder it becomes to distinguish between natural and artificial, especially when artificial has had millions of years to become natural. There's a moment in our own timeline that offers a glimpse of this: the Industrial Age. In just a few centuries, humanity has altered the composition of the atmosphere, oceans, and soil. We've created materials that didn't previously exist. We've redistributed elements across the planet in ways that would be highly unusual under natural conditions. If someone were to study the Earth millions of years from now, they might notice this layer, a thin boundary in the geological record, a moment where something changed. But would they know it was us? Or would they simply label it as an event, a shift, a transition, without understanding the cause? Now extend that idea backward. What if such a layer already exists, buried deep in Earth's history, a moment where the chemistry of the planet shifted in a way that doesn't quite fit known patterns, not dramatic enough to stand out clearly, but unusual enough to raise questions? We might have already found it and not realized what we were looking at. Because interpretation is everything. We don't just observe data, we explain it, and those explanations are shaped by what we believe is possible. If we believe that no intelligent species existed before humans, then any anomaly will be forced into a natural explanation, even if that explanation feels incomplete. This is where the idea of technological ghosts begins to take shape. Not machines, not ruins, but traces, echoes, subtle alterations in the fabric of the Earth that hint at processes beyond simple biology or geology. And ghosts are difficult to see, not because they aren't there, but because they don't behave the way we expect. There's another layer to this. Technology doesn't have to resemble ours. We imagine intelligence leading to cities, machines, industry. But what if a species developed along a different path? What if its technology was integrated with biology? Organic structures grown rather than built, energy harnessed through chemical or biological systems instead of combustion, materials that degrade cleanly, leaving no long-term trace. Such a civilization might reach extraordinary levels of complexity and leave almost nothing behind, not because it failed, but because it was efficient, in harmony with its environment, designed to disappear. That idea challenges something deeper. It suggests that the absence of evidence might not be due to destruction, but design. As we continue to explore this possibility, the line between natural and artificial becomes harder to define, because over deep time, everything becomes part of the same system. Everything is recycled. Everything is transformed. Everything is forgotten. So when we search for evidence of past intelligence, we may be asking the wrong question. We ask, where are the machines? But perhaps we should be asking, what changes did they leave behind? Because the answer might not be something we can see. It might be something we have to detect, something hidden in the chemistry of rocks, in the composition of the atmosphere, in patterns that don't quite fit the story we've been telling ourselves. And if those patterns exist, if there are traces of something that came before us, then the Earth is not just a record of natural history. It's a layered archive of events we don't fully understand. Some biological, some geological, and maybe, just maybe, some technological. But if even technology can vanish into the background of the planet, if even the most advanced creations can become indistinguishable from nature, then we are left with a deeper, more unsettling question. What if the evidence we're looking for isn't in the ground at all? What if the only traces left behind are patterns we haven't yet learned to read? Because sometimes the clearest signs of something extraordinary don't look like structures. They look like anomalies, and that's where the next layer of this mystery begins.
There are moments in science where everything seems to fit, where the data aligns, the explanations hold, and the story feels complete. And then there are moments where something doesn't quite belong. Not wrong enough to be dismissed, but not right enough to be understood. Those moments don't shout. They whisper. If the Earth has ever carried the traces of something older than us, something intelligent, something capable of shaping its environment, then time would have erased the obvious signs. No cities, no machines, no monuments. But it might not erase everything, because some changes linger, not as structures, but as patterns. Deep within layers of ancient rock, scientists study isotopes, variations of elements that carry subtle information about the conditions under which they formed. These isotopes are like fingerprints. They tell us about temperature, atmosphere, chemical processes. They help us reconstruct climates from millions of years ago, track volcanic activity, understand shifts in the planet's systems. But sometimes, those fingerprints are strange. There are moments in Earth's history where carbon levels shift in ways that are difficult to fully explain, where the ratio of isotopes suggests something altered the balance of the atmosphere, rapidly, abruptly, not over millions of years, but in relatively short geological windows. We call these events excursions, deviations from the expected pattern. They're often explained through natural causes, massive volcanic eruptions, methane releases, ocean changes.
And many of those explanations make sense, but not all of them feel complete. Because when you look closely, some of these shifts resemble something familiar, something modern. During the Industrial Age, humanity began releasing carbon into the atmosphere at an unprecedented rate. But more importantly, we released a specific type of carbon, one with a distinct isotopic signature tied to fossil fuels. If someone millions of years in the future were to study this period, they would notice it immediately. A sharp deviation, a clear signal that something unusual happened. Now imagine finding a similar signal deep in the past. Not identical, not conclusive, but suggestive. A layer where the chemistry shifts in a way that hints at rapid change. A moment where something disrupted the balance. Would we recognize it, or would we assume it must be natural because we believe nothing else is possible? This is the challenge of interpreting echoes, because echoes don't tell you the source. They only tell you that something made a sound. There are other anomalies too, unusual concentrations of rare elements, patterns in sediment layers that don't quite match expected environmental changes, structures that appear organized but are attributed to natural formation. Each one on its own is not enough to challenge our understanding, but together they form a quiet tension, a sense that the story might be more complex than we realize. And then there's the sky. For most of human history, the sky has been a source of wonder, a place of mystery, of patterns, of signals we are only beginning to understand. But it's also a record, not of Earth's surface, but of what reaches it. Cosmic rays, solar radiation, interstellar particles, all leave traces in the atmosphere and over time in the geological record. These traces can tell us about events far beyond our planet, supernovae, solar flares, changes in the cosmic environment, but sometimes the signals are unusual. There are bursts of radiation recorded in tree rings and ice cores, moments where something caused a sudden spike in energy reaching the Earth. Some of these events have explanations, others are still being studied, still debated, still uncertain.
Now imagine, just for a moment, a different possibility. Not that these signals are artificial, but that we don't yet understand all the processes that could create them. Because if intelligence existed before us, and if it developed technology, would all of its actions be confined to the surface? Or would it, like us, reach beyond? Humanity has already begun to leave Earth. Satellites orbit above us. Probes travel through the solar system. Signals, radio waves, transmissions spread outward into space. If we were to disappear tomorrow, those signals would continue, fading, weakening, but still moving. Echoes of our existence, traveling through the cosmos. Now extend that idea. Imagine a civilization that existed millions of years ago, one that reached a level of technological capability similar to ours, or perhaps very different. It might have left traces not just in rock, but in space. Artifacts that no longer orbit where they once did. Signals that have long since passed. But maybe, just maybe, something remains. A pattern, a signal, a structure in orbit that doesn't quite fit natural explanations. So far, we have found nothing that definitively points to such a past. But that doesn't mean the sky is silent. It means we are still learning how to listen. Back on Earth, the echoes continue. In stone, in chemistry, in patterns that don't quite align. There's a concept in science that's both powerful and limiting. Occam's razor, the idea that the simplest explanation is usually the correct one. It's a tool that helps us avoid unnecessary complexity. But it also has a shadow, because sometimes the simplest explanation is not the complete one. When we encounter an anomaly, we look for natural causes. We search for mechanisms that fit within our current understanding, and most of the time we find them. But every now and then, the explanation feels stretched, as if it fits, but not perfectly. Those are the moments where curiosity matters most, not to jump to conclusions, not to assume something extraordinary, but to remain open to the possibility that our understanding is incomplete. Because history has taught us something important. There was a time when we believed continents were fixed, that species never changed, that the Earth was only a few thousand years old. Each of those beliefs felt certain, until they didn't.
The idea that humans are the first intelligent species on Earth feels just as certain, just as foundational, just as unquestioned. But certainty can be fragile. If echoes of something older exist, they won't announce themselves. They won't appear as clear, undeniable proof. They will exist in the margins, in the anomalies, in the places where data doesn't quite align with expectation. And those places are easy to overlook, easy to explain away, easy to forget. But they are also where discovery begins. As we move forward, the question deepens, not just what evidence might exist, but whether we are capable of recognizing it. Because the greatest limitation may not be the absence of clues, but the framework we use to interpret them. What if intelligence doesn't leave the kind of echoes we expect? What if its traces are subtle, indirect, woven into the natural systems of the planet? What if the first intelligent beings didn't build outward, but inward? That possibility leads us into unfamiliar territory, a place where intelligence is not defined by tools or structures, but by something else entirely. Because to understand what might have come before us, we may need to rethink what intelligence itself really is.
We carry a quiet assumption wherever we go, that intelligence looks like us. It walks on land, it uses hands, it builds tools, it leaves marks, cuts stone, shaped metal, organized structures that stand apart from nature. Even when we imagine other intelligent beings, on distant planets or in deep time, we tend to reshape them in our image. Different faces, different forms, but the same underlying idea. A mind like ours, a world shaped like ours, a story that unfolds in familiar ways. But what if that assumption is the very thing blinding us? Because intelligence, at its core, is not about hands or tools or cities. It's about the ability to process information, to adapt, to learn, to respond to the environment in ways that go beyond instinct. And those abilities don't belong exclusively to us. Look at the ocean, not the surface, but the depths. A vast, dark world that has existed far longer than any land ecosystem we know today. Pressure beyond imagination, no sunlight, strange chemistry, life forms that seem almost alien in their design. And yet, life thrives there, complex, adaptive, mysterious. Some of the most intelligent creatures on Earth don't build anything permanent. They leave no cities, no monuments, no lasting marks. And yet, they think, they solve problems, they communicate. Consider the octopus, a creature with no bones, no rigid structure, capable of squeezing through openings no larger than its eye. It can change color and texture instantly, blending into its surroundings with astonishing precision. It solves puzzles, it opens containers, it learns through observation. Its nervous system is distributed, its arms can process information independently, almost as if it has multiple minds working together. And when it dies, almost nothing remains. No skeleton to fossilize, no lasting structure to preserve its existence. Just a brief imprint in time. Now imagine a lineage like that, given millions of years. Not constrained to land, not dependent on tools in the way we are, but evolving in an environment where flexibility, adaptation, and intelligence take different forms. Would it build cities, or would it shape its world in ways that leave no trace? There are creatures on Earth that communicate through light, others through chemical signals, some through vibrations in water or air. Intelligence does not require language as we understand it. It does not require writing or architecture or even technology in the mechanical sense. It only requires the ability to understand and to act. Now push that idea further. What if intelligence once emerged in the ocean, long before land-based ecosystems became dominant? An ancient marine species, evolving over tens of millions of years, developing complex behaviors, perhaps even forms of culture or knowledge, but without fire, without metallurgy, without the need to build structures that last.
Because underwater, things are different. Fire doesn't burn. Metal corrodes faster. Structures are harder to maintain. The environment itself resists permanence. So intelligence in that world might take another path, not building outward, but adapting inward, becoming more efficient, more integrated with the environment, more subtle.
Such a species might not leave tools. It might leave patterns, changes in ecosystems, alterations in species behavior, but over millions of years, even those patterns would fade, blended into the natural evolution of life. And when it disappears, there is no ruin, no fossil, no clear evidence that it was ever there. Just silence. There's another possibility, one that feels even more distant from our understanding. What if intelligence didn't belong to a single organism at all? On Earth, we see hints of collective behavior everywhere. Colonies of ants functioning as a single system, beehives making complex decisions through distributed signals, even forests connected by underground fungal networks, sharing nutrients, responding to threats, communicating in ways we are only beginning to understand. These systems are not conscious in the way we are, but they are coordinated, adaptive, responsive. Now imagine that taken to another level, a network of organisms connected not just physically but functionally, sharing information, processing inputs, acting as a unified system. Not an individual intelligence, but a distributed one. Would we recognize it, or would we see it as an ecosystem, a natural process, something without intention? If such a system existed in the past, on land, in the ocean, or even spanning both, it might have reached a level of complexity we don't associate with intelligence. It might have shaped its environment in subtle ways, maintained balance, adapted over time. And when it ended, there would be no single point of failure, no collapse of cities, no sudden disappearance, just a gradual fading, a slow return to simpler systems. Again, no trace. This is where our definition of intelligence begins to feel limited, because we define it based on what we are: tool makers, builders, storytellers who leave marks behind. But intelligence might not always need to leave marks. It might exist in forms that are temporary, fluid, integrated with the environment rather than separate from it. And if that's true, then the absence of evidence becomes even less meaningful, because we are not just searching for something that has been erased, we are searching for something that may never have left the kind of evidence we expect. There's a quiet irony in this. We often think of ourselves as the most advanced form of life Earth has ever produced, but our intelligence is tied to a very specific path: fire, tools, industry, technology that externalizes our thinking into the world. But that path is not the only one. It's just the one that led to us. Another path might lead somewhere else entirely, to intelligence that doesn't build machines, that doesn't reshape landscapes, that doesn't leave a lasting geological signature. And such intelligence, if it existed, would be almost impossible to detect, not because it wasn't real, but because it didn't interact with the world in the way we expect intelligence to. As we begin to accept that possibility, something shifts. The question is no longer just, were we the first? It becomes, what kinds of intelligence might have existed that we are incapable of recognizing? Because if intelligence can take many forms, if it can exist without leaving fossils, without building structures, without altering the planet in obvious ways, then Earth's past becomes far more mysterious than we ever imagined. It's no longer a simple story of evolution leading to us. It's a landscape of possibilities, paths taken, paths lost, paths we may never fully understand. And somewhere within that landscape, there may have been minds, not human, not familiar, but aware. If that's true, then intelligence is not a singular event in Earth's history. It's something that could emerge, disappear, and emerge again. Which leads us to a deeper, more unsettling idea, not just that intelligence might have existed before us, but that it might not have been the last time it happened. Because Earth has a history of starting over, again and again. And in that cycle, intelligence may not be the exception.
it may be part of the pattern.
There is a rhythm to Earth. Not a gentle one, but a relentless, repeating pattern that has shaped life for billions of years. Creation, expansion, collapse, and then silence. We often think of life as a steady climb, a slow, continuous rise from simplicity to complexity, from primitive organisms to intelligent beings like us. But the history of Earth tells a very different story. It's not a straight line. It's a series of resets. At least 5 times in Earth's past, life has been nearly wiped out. Not gradually, not quietly, but suddenly and on a massive scale. These are known as mass extinctions, events so powerful they reshape the entire trajectory of life on the planet. And each time they happen, the story begins again. The most famous of these is the Cretaceous-Paleogene extinction event. A massive asteroid strikes Earth. The impact sends shockwaves across the planet. Fires rage. Dust fills the atmosphere, blocking sunlight. Temperatures drop. Ecosystems collapse. Within a relatively short period of time, the dominant species of the era, the dinosaurs, are gone. Not weakened, not reduced, gone. And yet, life doesn't end. It waits, in small pockets, in hidden corners, in resilient forms that survive the chaos. And then, slowly, it begins again. New species emerge, new ecosystems form, and eventually, entirely new paths of evolution take shape. But that was only one reset. There were others. The Permian-Triassic extinction event was even more devastating. Often called the Great Dying, it wiped out around 90% of all species on Earth. Oceans became toxic, land ecosystems collapsed, entire branches of life disappeared. For a time, the planet was almost empty. Imagine that. Not a world teeming with life, but a world recovering from near total collapse. A world where complexity had to rebuild itself from the ground up. And yet, it did. Again. Each extinction is like a reset button. Not a complete erasure, but a drastic simplification. Complex systems collapse into simpler ones. Dominant species vanish, leaving ecological space open for something new. And over millions of years, that space fills. Life adapts, evolves, diversifies. Now step back and look at that pattern, not as isolated events, but as a cycle. Rise, expansion, collapse, rebirth. If intelligence is part of evolution, then it too exists within that cycle. We often imagine intelligence as the final stage, the peak, the end point of a long evolutionary journey. But what if it's not an end point at all? What if it's just another phase? A phase that can be reached and lost. Consider this. The dinosaurs ruled the Earth for over 160 million years. That's more than 500 times longer than humans have existed. In that vast span of time, evolution had countless opportunities to experiment, to produce new forms, new adaptations, new possibilities. Could intelligence have emerged during that time? Not necessarily in the way we understand it, not necessarily building tools or structures, but in some form, behavioral, cognitive, adaptive. If it did, what would happen when the extinction came? The asteroid doesn't discriminate. It doesn't care about intelligence. It doesn't preserve knowledge. It doesn't protect complexity. It resets everything. Any intelligent species, no matter how advanced, would face the same fate as everything else: collapse, extinction, or survival in reduced, fragmented forms. And if that species didn't survive, its story ends completely. No memory, no continuation, no legacy beyond what the Earth happens to preserve. Now imagine this happening not once, but multiple times, across hundreds of millions of years. Intelligence emerges, it develops, it reaches some level of complexity, and then a reset. The cycle continues. Each time the conditions are different, the species are different, the environments are different.
and each time the outcome is uncertain. Some cycles may never produce intelligence at all. Others might produce it briefly, only for it to vanish before leaving a lasting trace. And occasionally, one might last long enough to reshape the planet. But even then, time will eventually erase it. This idea changes the way we see ourselves, because it suggests that humanity is not the first step, not the beginning, but part of an ongoing process. We are one iteration, one moment in a cycle that has been repeating long before we existed. And that cycle does not guarantee permanence. There's a tendency to believe that once intelligence arises, it becomes self-sustaining, that it can protect itself, adapt to any challenge, overcome extinction. But history suggests otherwise. Even our own civilization, advanced as it is vulnerable to environmental collapse, to global conflict, to events beyond our control. We are not outside the cycle. We are inside it. And that raises a deeper question. If intelligence has emerged before and been erased, then what determines whether it survives? Is it technology, resilience, luck? Or is extinction inevitable? Because if extinction is part of the pattern, then intelligence may not be a permanent feature of Earth. It may be something that appears, disappears, and appears again. And if that's true, then the silence of the past is not just the absence of evidence. It's the result of repetition, stories that began and ended before we ever arrived, stories that left no lasting trace because the cycle erased them. As we move toward the final chapter, the implications become harder to ignore. If we are not the first, if intelligence has come and gone before us, if the Earth has reset itself again and again, erasing even the most complex forms of life, then what does that mean for us? Are we just another chapter in a story that keeps repeating? Or are we something different, something that might finally break the cycle? Because the answer to that question doesn't just change how we see the past, it changes how we see the future, and whether that future is something new or something that has already happened before.
There is a moment, quiet, almost invisible, when an idea stops feeling like fiction and starts feeling like a possibility. Not proven, not confirmed, but no longer impossible. If you followed this journey from the beginning, something subtle has shifted. At first, the question felt distant. What if humans aren't the first intelligent species here? It sounded like speculation, a thought experiment, something interesting, but unlikely. But now, after peeling back the layers of time, after stepping through lost worlds, incomplete records, vanishing technologies, unfamiliar forms of intelligence, and cycles of extinction, that same question feels different, heavier, closer. Because we haven't found proof that we were first. We've only found reasons to believe we might not be. And that distinction matters. The Earth is not a perfect archive. It does not preserve history cleanly or completely. It erases, reshapes, recycles. It hides more than it reveals. And within that vast, shifting system, entire stories could have unfolded and vanished without leaving behind the kind of evidence we expect. So the possibility remains, not loud, not obvious, but persistent. That we are not standing at the beginning of intelligence on this planet. We are standing at the edge of something that has happened before. If that's true, then everything changes, not just our understanding of the past, but our place within it. Because for most of human history, we've seen ourselves as the first to awaken, the first to ask questions about existence, the first to look up at the stars and wonder what lies beyond. But what if we're not the first to wonder? What if, millions of years ago, under a different sky, on a different arrangement of continents, something else looked up? Not human, not familiar, but aware. What questions did it ask? What answers did it find? And perhaps most unsettling of all, what happened to it? Did it disappear suddenly, caught in one of Earth's great resets? Did it fade slowly, adapting until it became something unrecognizable? Or did it reach a point where it changed the world so completely that the evidence of its existence became part of the natural system itself?
We don't know. And that uncertainty is not a weakness, it's an opening. Because it forces us to confront something deeper than history. It forces us to confront perspective. We are used to thinking of ourselves as the center of the story, the latest, most advanced chapter in a long progression. But if intelligence has emerged before us, then we are not the center. We are part of a pattern. A pattern that may not care whether we succeed or fail. A pattern that has played out across millions of years, shaping life in ways we are only beginning to understand. And that realization carries weight. Because it means our future is not guaranteed. We like to believe that progress is permanent, that once knowledge is gained, it cannot be lost, that once a civilization reaches a certain level, it can sustain itself indefinitely.
But history, both human and geological, suggests otherwise. Civilizations collapse, knowledge fades, environments change, and sometimes the forces that shape the planet itself intervene. If others came before us and vanished, then their disappearance wasn't just a historical curiosity, it was a warning. Not a message carved in stone, not a signal sent across time, but a pattern, a quiet repetition of emergence and extinction. And we are inside that pattern. So the question is no longer just about the past. It's about us. If intelligence has appeared before and been erased, what makes us different? Is it our technology? Our ability to record information? Our growing understanding of the planet and the universe? Or are we following the same path, unaware of where it leads? Because there's another possibility, one that feels both hopeful and unsettling. What if we are the first to realize this? Not the first to exist, not the first to think, but the first to look back deeply enough to question whether we are alone in our own past. That awareness changes something. It gives us a choice. If we are part of a cycle, we can ignore it, continue forward, assuming permanence, believing that what we build will last. Or we can learn from the possibility that others may have come before us, that intelligence is not a guarantee of survival, that progress does not protect against collapse, and that understanding might be the only thing that allows us to break the pattern. Because breaking the cycle doesn't mean avoiding extinction entirely. It means recognizing the forces that shape it, preparing for them, adapting in ways that go beyond instinct or short-term thinking. It means thinking not just in years or centuries, but in deep time, because that's the scale on which the Earth operates. And if we are to endure, we must learn to see ourselves not just as individuals or even as a civilization, but as a moment within a much larger story. A story that may have been written before and may be written again. There's a final thought that lingers, quiet but impossible to ignore. If intelligent beings existed before us, and if they asked the same questions we are asking now, and if they looked at their world and believed, even for a moment, that they were the first, then somewhere in the distant past, there was a moment just like this one, a moment of awareness, of curiosity, of possibility, and then silence. The difference is, we are here now, aware of that silence, aware that it might not be empty, and that awareness gives us something they may not have had, a chance, not to prove we are the first, but to decide whether we will be the last. Because in the end, the question is no longer just, what if humans aren't the first intelligent species here? It becomes something far more personal. What kind of species do we choose to be, now that we know we might not be alone in our own past?